Hello everybody and welcome to another machine learning video for our great course machine learning. And in this video I want to start by defining or giving a definition to machine learning. Machine learning is where computers learn to solve problems without being explicitly programmed to do that. So what we're going to see in this video is a brief definition for machine learning and learning itself, supervised learning, unsupervised learning, and the estimated function, or what many people like to call it, hypothesis function. So what's machine learning? What's learning itself? The process of learning is to improve the skills in a certain task after a certain amount of training. So, for example, we train a computer to play chess just by giving the computer like making the computer watch chess games and many chess games. By time, the computer gonna learn to play chess even better than the people he learned from. Another very famous example is classifying emails as a spam or not spam. For example, if you have ever wondered how your service provider, for example, Google and Gmail, classify so precise your emails to spam and not spam emails, it's a machine learning algorithm doing that. And by the end of this course, you're going to be able to do that also. So yeah. Supervised learning. In supervised learning, we are given a set of examples, and be careful with the terminology. It's so important. So we give a set of example. What's example? Example is, for example, you have a function f of x. The example is the x and the y. The y is the result of f of x. So examples are x's and y's, like the input and the output of a function. So we give a set of examples, and based on this set of examples, the machine learning algorithm gonna learn to predict the result of a new given x. Let's elaborate more. So for example, you have like sizes of houses. For example, you have a friend, and this friend wants to move to a new house. So he says, okay, here is the data. Here is many houses in with different sizes and different prices. And you see here this chart of data. So you see here a house that worth that is 500 feet square. It's worth almost like $150,000. $150,000. It's in K dollars. So you can. This is like a set of example. So the X here is the size, and the Y is the price. So, as a human being, naturally, what you're gonna do to predict for example, your friend wants a house of 1,000 feet square. As a human being, you're gonna say, okay, a house of 1,000, you're gonna kind of draw a line here, and you're gonna say probably 200,000 K. You're gonna say like that as a human being. So what we want to do is to teach the computer to do that, to do exactly what you did, to predict the price by using the same method, which is draw a line like that, and then go up from the given size to find the adequate price. Okay, and the computer gonna say roughly 150K based on the line. So this is just an example. So do you think there is a better solution for that? Maybe because more natural solution. If you see here, for example, if your friend has a big family and he wants really large house, so roughly here, you can't say like the price here, because you know that like the line is lying to you. Like from here up it's not the same, so because the price is kind of flattening here. So quadratic function may be more suitable to the data. So quadratic function can be like better than just any function. I mean better than the linear function. So this kind of problem is called regression problem, because we have continuous values, like the prices. You say here the price like 100, 150. These continuous values, so we call it a regression problem. Another example is breast cancer. For example, which is really important task and really useful to predict if a breast cancer is malignant or not based on the tumor size. So given the size of the tumor, you can know if the tumor is malignant or not by giving 0 or no, because yes or no, it's like just two possible answers. So yeah, this is an example of classification problem, by the way. This is called classification. The other one was called regression problem, and this is classification because we are classifying the tumor as malignant or not. So the class of yes and the class of no. But we wanted to move, what if, of course it's a health problem, so we definitely want to be as precise as possible. So what if we want to be more accurate in defining it's malignant or not? We can simply add more variables, predict yes or no based on more values, just not just tumor size, also the age of the patient, for example. So if we model it like this, so we have the tumor size and the age, we have kind of this is a set of the not malignant tumors, and this is the malignant tumors. So you can roughly segregate the data using a line like this. We can add even more features, but we need to choose carefully. Of course, you would want to choose carefully your variables, because sometimes you add variables that doesn't really improve the model, and sometimes it's actually making the model worse. So there is many methods in the world of machine learning to choose the right variables, and maybe we're gonna encounter one of these in our course. Unsupervised learning. So unsupervised learning is trying to make groups or clusters, and remember this terminology, clusters, from a given data without any prior knowledge. So what does that mean? Let's go back to if you think about our example of tumor sizes and age. For example, this is tumor size and this is age. We give the algorithm the tumor size and the age, but we don't give it the answer. Is it malignant or not? We don't give it that answer. We just give it the tumor size, the age, and we want the algorithm itself to group the malignant cancers together, cancer situations together, and the non-malignant cancer situations together, like that. Or it's called also clustering, and this is unsupervised learning. So given a set of articles, that's another example. Given a set of articles, classify the ones with the same story in one group. Actually, Google does that in, I'm not sure what's the name, Google Articles or Google News, something like that. But the point is, it gets a lot of articles and classify these articles based on the content, or like if two articles has the same story, it gets classified in one group together. So what we need to do in supervised learning, we have a training data x and y, for example size of house and price. So given the x and y, we want to create a function. That function, when we give it the x, or the size of a house as an example, it gives us the price. In other words, fx equals y. So that's another elaboration. Training set like x and y, we give it to our learning algorithm. The learning algorithm like estimates a function, as I called before, estimated function or hypothesis function. And in our example of houses and prices, we saw the line that we draw. We want our algorithm, that's the line. The line is our function, is the thing that we want to construct. After our learning algorithm constructs this function, we give it new x, and it gives us a new y, but it's the right y, like the exact right y, or prediction, you can call it. So in linear regression, actually we're gonna have a complete chapter after this video about linear regression. So if you don't understand anything now or still confused, don't worry, we're gonna see it all in detail. So for the next few videos, we are going to talk about linear regression. We will start, by the way, let's see first this. So this is what we want to do. Like, we want to make an algorithm that draw this line. So if you are familiar with high school mathematics, you remember that the equation for a linear function, this is what's called linear function, is ax plus b, or in other words, as I call it here, w0 plus w1 multiplied by x. So what you notice here is that the x is going to be given. Like, you remember when your friend asked you, oh, I'm going to buy a house, I want to buy a house with 1000 feet square. So 1000 feet square, that means your friend gave you the x, okay? Then he wants you to give him the y. So what you need to calculate all this equation, you already have the x. You just need the w1 and the w0. So our learning algorithm is going to estimate the w1 and the w0. And when we estimate the w1 and the w0, we can draw this line and predict. And by the way, another thing I want to point out is we will start with one variable, which is the price. But you remember our example of cancer. Like, we started by tumor size, and then to make our example more precise, we also used the age of patient. So we're gonna do the same. Like, we're gonna learn just using one variable, for example the price, and then we're gonna start doing like with more variables. So thank you very much. This was our machine learning introduction, and we already saw some really good concepts. And yeah, thank you very much. If you are still confused, just like try to repeat the video, or try to come to the next video, because I'm gonna like elaborate more, and it's gonna be a lot easier for you next video. Thank you very much, and see you next video.